In the module Electromagnetism, students learn that a magnet is an object that attracts other magnetic materials, such as iron, or materials that contain them, such as steel. This attractive force is called magnetism. Magnets share certain characteristics. A magnet can attract magnetic materials. Every magnet has two poles that are equal in strength. A magnet's force is strongest at its poles. Like poles repel and unlike poles attract. The law of magnetic attraction, and each magnet is surrounded by an invisible force called its magnetic field, which can act on a magnetic object from a distance. Although today it is well known that magnetism and electricity are linked, this fact was not established until the 19th century. In 1820, Hans Christian Ørsted discovered that an electric current naturally produces a magnetic field. 10 years later, Michael Faraday discovered that the opposite was true as well. An electric current can be induced in a wire by passing it through a magnetic field. These fundamental principles are called electromagnetism. Electromagnetism makes possible the use of powerful electromagnets. An electromagnet is made by coiling a wire around an iron core. When an electric current is run through the wire, the magnetic field it produces magnetizes the iron core. The major difference between magnets and electromagnets is that the magnetism produced by the electromagnet can be turned on and off. An electromagnet is a temporary magnet. In this Delta Science module, students will learn that magnets are much more than just objects that hold notes against refrigerator doors. Electromagnetism, made possible by magnets, has many important applications in our technological society, including motors, solenoids, and generators. Students explore one of the fundamental physical forces in nature, electromagnetism. Students first investigate the properties of magnetism, magnetic interaction, magnetic fields, polarity, attraction and repulsion of like and unlike poles, and the cumulative strength of multiple magnets. Compass needle deflections indicate to students that, like a magnet, an electric current creates a magnetic field, and the connection is made between electricity and magnetic force. Students construct an electromagnet and two useful electromagnetic devices, a telegraph and a buzzer. Then they make simple and complex motors, observing how the fields of electromagnets and permanent magnets interact to produce rotation. In the Delta Science Reader, Electromagnetism, students discover what electricity is and read about static electricity, current electricity, and electric circuits. They learn about magnets and magnetism and discover how electric current is used to make electromagnets. They also find out how generators produce electricity and how electric motors work. In a biographical sketch, they are introduced to a famous scientist, Samuel Morse, and his invention of both a practical telegraph system and the signaling code that was named after him. Finally, students learn about the many uses of electromagnets.